Patil. So today in this video we discuss about the Einstein equation, or we can say that Einstein coefficient. So this Einstein equation or coefficient depends upon three things. So first one is the rate of absorption. So already in last lecture we discussed about the absorption, spontaneous emission and stimulated emission. So here this rate of absorption depends on two things. First one is number of atoms at ground state, and second thing, this rate of absorption depends upon the energy of incident photon. That is E is equal to h mu. Okay. So this rate of absorption depends upon number of atoms at ground state, and it depends upon energy of incident photon, that is h mu. Okay. So we can write this gamma absorption is proportional to N1 into Q. Now here this N1 indicates number of atoms present in the ground state, and this Q is nothing but the energy, and that energy required for transition from E1 to E2. So this is nothing but the rate of absorption. So we can write this equation like this, that is gamma absorption is equal to B12 into N1 into Q. So this B12 represents the proportionality constant. Give equation number 1. Okay. Now second thing, this Einstein coefficient depends upon rate of stimulated emission. Now here also this rate of stimulated emission depends upon two things. First thing, it depends upon number of atoms at upper state, or we can say that the number of atoms present in the excited state. And second thing, again this rate of stimulated emission depends upon the energy of photon, that is h mu. So we can write equation for rate of stimulated emission like this: gamma stimulation is proportional to N2 into Q. Now here this N2 represents number of atoms present in an upper state, or we can say that number of atoms present in an excited state, and this again this Q represents energy required for the transition from the upper state to the lower state. So we can write this equation like this: gamma stimulation is equal to B21 into N2 into Q. This is equation number 2. Now here this B21 represents the proportionality constant. Okay. Similarly, now third thing, that is rate of spontaneous emission. Now here this rate of spontaneous emission depends upon only one thing, that is spontaneous emission depends upon number of atoms present at a upper state or excited state. Now this spontaneous emission is a natural process, so this emission does not require the energy. Therefore this rate of spontaneous emission is independent on the energy and depends upon number of atoms present in the excited steady state. And therefore, we can write this equation like this: gamma spontaneous is proportional to N2. Again, we can write this equation like this: gamma spontaneous is equal to A21 into N2. Give equation number 3. Okay. Now this equation 1, 2 and 3 we can show in this figure. Now this first thing, that is gamma absorption. Now this second one is gamma stimulation, and this third one is gamma spontaneous. Okay. Now after that, from this equation first, second and third, or another thing, in thermal equilibrium total energy remains constant. Hence, we can write number of photon absorbed per second must be equal to number of photon emitted by stimulated emission and spontaneous emission. And therefore, we can write the equation gamma absorption is equal to gamma stimulation plus gamma spontaneous emission, like this. Now from equation 1, 2 and 3, we just put out the values of gamma absorption, gamma stimulation and gamma spontaneous emission. So from equation 1, we just put B12 N1Q. Okay. Again, from equation 2, we put B21 En2Q, and from equation 3, we just put A21 into En2. Okay. Now here, from this equation, Q will take common. Therefore, right side term will take into the left side. Therefore, we can write this equation like this: B12 N1Q minus B21 En2Q, and right side term we can write as it is, that is A21 into N2. Okay. Now Q will take common. Therefore, B12 N1 minus B21 N2, like this. Okay. Right side term we can write as it is. Okay. Now again, from this equation we can write Q is equal to A21 into N2 divided by B12 N1 minus B21 into N2. Okay. Now again, dividing by N2. So we can write this equation like this: A21 divided by B12 divided by B12 N1 divided by N2 minus B21. Give equation number 4. Therefore, this equation 4 is nothing but the Einstein equation, or we can say that Einstein coefficient. Okay. One more time I will explain. So Einstein equation, or we can say that Einstein coefficient. What happens? This Einstein coefficient depends upon 3 factors. First one is the rate of absorption. So this rate of absorption depends upon number of atoms at ground state and energy of incident photon. Therefore, we can write the equation gamma absorption is proportional to N1 into Q. Now this N1 represents number of atoms present in the ground state. This Q indicates energy required for the transition from lower energy to the higher energy. And therefore, we can write this equation like this: gamma absorption is equal to B12 into N1 into Q. equation number 1. Now second factor, that is rate of stimulated emission. Now this rate of stimulated emission depends upon number of atoms present in the excited state, and one more thing, it depends on energy of photon, that is hν. Okay. Therefore, we can write the equation gamma stimulation is proportional to N2 into Q. Now here, this N2 represent number of atoms present in a upper state, and this Q is nothing but the energy of the photon. Okay. Therefore, we can write this equation like this: gamma stimulation is equal to B21 into N2 into Q. Give equation number 2. Okay. Now third factor, that is rate of spontaneous emission. Now this rate of spontaneous emission, or we know that spontaneous emission is a natural process, so it does not require the energy. Okay, so this rate of spontaneous emission depends only on the number of atoms present in the excited state, or we can say that this spontaneous emission independent on the energy. Okay, and therefore we can write the equation gamma spontaneous is proportional to N2. Now this N2 represent number of atoms present in the excited state. Therefore this equation we can write like this: gamma spontaneous is equal to A21 into N2. Give equation number 3. Now these equations, that is equation 1, 2, 3 shown in this figure. This is the gamma absorption, that is the rate of absorption. Okay, this is the rate of stimulated emission, and this is the rate of spontaneous emission. Okay, now after that, in thermal equilibrium, what happens? Total energy remains constant, and hence number of photon absorbed per second must be equal to the number of photon emitted by stimulated emission and spontaneous emission. And therefore, we can write the equation gamma absorption is equal to gamma stimulation plus gamma spontaneous. Okay. Now from equation 1, 2 and 3, we just put out the values of gamma absorption, gamma stimulation and gamma spontaneous. Therefore, equation becomes B12 into N1Q is equal to B21 N2Q plus A21 into N2. Now from this equation, Q will take common. Therefore, right side term will take into the left side like this. So B12 N1Q minus B21 N2Q is equal to right side term A21 into N2. We can write as it is. Okay. Now after that, after taking the Q common, we get this equation, and therefore Q is equal to, we get A21 into N2 divided by B12 into N1 minus B21 into N2. Now after this, dividing by N2, we get the equation, final equation Q is equal to A21 divided by B12 into N1 divided by N2 minus B21. Give equation number 4. And therefore, this equation 4 is known as Einstein equation or Einstein coefficient. Thank you. Now, one more point we will discuss, that is the application of lasering. Now, first we will discuss medical application. Very simple phenomenon is there. Medical application. First medical application, the laser is used in eye surgery. Okay, eye surgery purpose the laser can be used. Now, second medical application is it is used for a cancer treatment. Okay, third medical application, and we can write here cancer treatment, again eye surgery. Okay, now next application, this laser is used to destroy the kidney stone. For that purpose also the laser can be used. Okay. Now next medical application is there. This laser is used for the plastic surgery. Okay. Again, it is used to remove the moles, tumors. So like this, these are the application of laser. Okay. Now after that, we discuss about the industrial application. Now first industrial application, that is welding. Now laser can be used to join the this laser can be used to weld the joints of metal. So for joining the two metals, the laser can be used. Okay. Now second one is the cutting. For cutting purpose also laser used. So laser can cut very hard and very hard metal sheets. Okay. And third industrial application, that is welding, cutting and drilling. Now laser can drill a hole of 10 micron diameter through very hard substance like a diamond. So for drilling purpose also laser can be used. Okay. Now third application of laser, that is military application. So for military purpose also laser can be used. Okay. To destroy the enemy's aircraft, missiles, tanks, etc. Okay. Now next application of laser, that is communication application. That is for communication purpose also laser can be used. For example, it is used in optical fiber communication for transmitting the signals, audio video signals, or for transmitting the data for a long distance without any loss. So for simply we can say that for communication purpose also laser can be used. One more application is there for underwater communication also the laser can be used. Okay. So these are the applications of laser. Okay. Now one more time we discuss that is medical application. First application, it is used for the cancer treatment. Again, it is used for eye surgery. Again, it is used to destroy the kidney stones. Next application, that is medical application, it is used for the plastic surgery to remove the moles, tumors, etc. etc. Okay. Now one more medical application is there, that is it is used for painless drilling of the tip or bones. For that purpose also laser can be used. Okay. Now second application is there, industrial application. Now first industrial application is welding. For welding purpose for welding purpose laser can be used. That is laser used as a heat source, and due to this this laser can join the two metals. Okay. Now second industrial application, that is cutting. Now this laser can cut very hard and thick metal sheets. Okay. Third industrial application, that is drilling. For drilling purpose also the laser can be used, and laser can drill the 10 micron diameter, or laser can drill hole of 10 micron diameter through the very hard substance like a diamond. Now this is the industrial application. Now for military purpose also laser can be used to destroy the enemy's aircraft, missiles, tank, etc. Okay. And last one is laser can be used for the communication purpose also. That is, it is used in optical fiber communication for transmitting video signals, audio signals. Also it is used for transmitting the data for a long distance without any loss. Okay. One more application is there, that is this laser can be used for underwater communication. Okay. So these are the application of laser.